Hi, my name is Andrew. I'm a software engineer with the AWS RoboMaker team. I'm going to be talking to you today about simulation with RoboMaker in ROS and Gazebo. So today we're going to go over the specifics, what's in and out of the presentation. We'll give an overview of the AWS RoboMaker architecture and the different features we've defined there. And then we'll walk through actual simulation with AWS RoboMaker. We'll pop open the console in the IDE, start a simulation, and play around with some of the tooling that's available for you to interact with the simulation. And then throughout the webinar, we'll have questions, and we'll also have questions at the end. So before we get started, there's a couple of concepts that we expect you to be familiar with that we're going to be building on top of. Robot Operating System, or ROS, is the most widely used open source robotics software framework. It's not a classic operating system, but it provides software libraries which you can use to build and interconnect robotics applications. Gazebo simulation is used to test robots in different scenarios, oftentimes more quickly than you can with a physical robot. It lets you build 3D worlds, robots, and it has a physics engine for modeling different attributes of the world, like illumination, gravity, friction, and many other forces. It's super useful for testing things like error handling, battery life, navigation, and even training machine learning algorithms in simulation. So when we talk about the ROS ecosystem, we can separate it into kind of three big buckets. Language and platform independent tools to help you build and distribute ROS software. The actual ROS client libraries for different specific languages, ROS CPP, ROS Pi, and ROS Lisp, for example. And then packages containing application-related code, which you are writing or you're depending on when you're developing your robot software. So AWS RoboMaker is built with the ROS ecosystem in mind and Gazebo for simulation. So today we're going to be giving a live example of simulation in AWS RoboMaker with ROS and Gazebo, but we won't be diving deep into specifics on how to develop code in ROS or how to build resources inside of Gazebo. So with that, let's jump right in. So when we set out to create AWS RoboMaker, we identified a couple of specific issues we found with robot development today. Robot developers often don't start to simulate until later in their development process because they're really focused on writing the robot code and executing, getting the robot working. And the barrier to entry for starting simulations is so high that developers will often wait till they're later in the development cycle to get started with simulation. And if you're entirely new to simulating a robot in a physical world, it can take days or even weeks to get set up to begin simulating. So with these issues in mind, we put together 4 independent but interconnected offerings which make up the AWS RoboMaker capabilities. The first are our cloud extensions for ROS, where we're exposing AWS services directly in the ROS ecosystem. We created developer tools and first-class integration into the Cloud9 IDE to allow developers to get started right away if they don't already have a development environment set up. We created a simulation service, entirely serverless service with pay-as-you-go pricing for running your simulation for multiple different use cases. And we have a fleet management service for over-the-air deployment directly to your physical robot. So our cloud extensions for ROS target specific robotic developer functionality that has supporting AWS services. So if you're interested in doing computer vision, we offer a cloud extension for Amazon Kinesis and Amazon Recognition. For voice interaction, voice commands, or voice out, we offer cloud service integration with Amazon Lex and Amazon Poly. And then for monitoring and logging what exactly is going on your physical robot or your robots in your fleet, we have a cloud service integration with Amazon CloudWatch. We'll take a look at some of these different cloud service integrations working in simulations a little bit later in the presentation. For the development environment, we work closely with Cloud9 to create a modified Cloud9 development environment specifically for building robots with ROS. It comes pre-configured with all the ROS tooling you need to build, bundle, and deploy simulations into AWS RoboMaker. It also has our sample applications built in, and it's a fully featured IDE. So our simulation service serves two use cases. We support regression testing with simulation in the cloud, as well as a software development loop with simulation running in the cloud. It's pre-installed with open source tooling from the community that you can use to interact with the simulation when it's running. We'll dive into each one of those a little bit later. It's a serverless pay-as-you-go offering. We think this is undifferentiated heavy lifting that we're really excited to make available for the development community. And we support monitoring and logging directly into CloudWatch of your running simulations, so you can keep an eye on them as they're executing. Lastly, our fleet management service offers robot registration and management for registering individual robots or fleets, managing fleets of robots. We have over-the-air deployment directly to the physical robot using AWS Greengrass. So today we're going to be focusing mainly on the developer use case as well as simulation with AWS RoboMaker and highlighting some of the cloud service integrations. So just to get a feel for the different components that make up the AWS RoboMaker architecture, specifically what is in the service account as well as what will be provisioned in the developer's account. When we talk about those big boxes, the development features, the Cloud9 IDE and the backend EC2 instance will all live in the developer's account. The simulation and deployment services are housed entirely behind the RoboMaker service. When we're starting up simulations and writing log files back, we're integrated directly with S3 resources in the developer account, as well as any AWS services that the executing code reaches out to will be housed inside the developer account. And then when we're up and running, AWS RoboMaker takes care of all the networking and plumbing to connect to those buckets to read and write, as well as exposing the different tooling directly to the console. And when we do deploying over the air to the physical robot. Taking a step into the development environment, we've got a simple software development lifecycle supported in AWS RoboMaker for building, bundling, and simulating your robot software. The first step is to build using our Colcon build tool. We chose Colcon because it allows us to build both ROS1 and ROS2 applications. It comes pre-installed on our Cloud9 IDE, and you can install it directly into your existing development environment if that's easier for you. The build process will build your code. The bundle step will take that built code and all of its dependencies and bundle it into two resources, our simulation application and robot application. I'll talk a little bit later on about what is specifically in each one of those. Once it's bundled, we upload it to S3, and from there we can start a simulation. And then that process can be repeated for the development use case as we discover the behavior of the robot in simulation. So let's talk a little bit about what happens on the simulation instance once we start up a simulation. The first thing we do is we'll reach out to the S3 bucket in the developer's account to pull in the simulation application and the robot application. We'll start ROS and Gazebo up and we'll begin the simulation. If you've requested to get the output from the running simulation, we'll write larger files like ROS bags and the simulation logs back out to the S3 bucket in your account, as well as standard out and standard error for both the simulation and robot application will be written to CloudWatch logs. and any metrics you have. It will be written to CloudWatch metrics. If your simulation needs to reach out to resources in your account or to the general internet, you can configure a networking endpoint into your own VPC, which the code running in simulation can use to access those external resources. And then lastly, we spool up several GUI tools, which allow you to interact directly with the running simulation from our console. We've got Gazebo client, RViz, RQT, and a basic terminal, and we'll dive into what each one of those is a little later on in the live demo. All right, so we've gone over the different components that make up the AWS RoboMaker service, where they live. We took a look at the developer software development lifecycle using our build tooling, as well as some of the components that make up the simulation as it's running. Now, I mentioned simulation in robot applications earlier. This is a concept that we introduced. All of the normal ROS packages and Gazebo resources that you would use if you weren't developing with AWS RoboMaker are unchanged. We've just separated them into two bundles. What we call our robot application, which is all the ROS code, nodes, and topics you need for your robot to work. It's effectively everything which will eventually be deployed to the physical robot. And then the simulation application, which is everything else that you need to simulate. So the simulated world, models, physics, lighting, any plugins you have for sensors, your models and joints, etc. So we've separated these apart so that eventually when you're done simulation, if you want to deploy directly to the robot, you've already got a robot application ready to go. Now, these concepts aren't inflexible. If you have a use case where you want to use just a simulation application or just a robot application, we support those as well. But for the rest of this demo, we're going to assume that we have both in our simulated application. Okay, let's jump into an actual demo of AWS RoboMaker. So I've dropped us in here to the sample applications page. I'm going to create a simulation job, and then we'll go through and explore the different components of it. We'll open up the GUI tools and interact with the running simulation. And then we'll create an IDE and explore some of the development features that are available in the IDE. So I picked the sample application page because it's the easiest way to get a sample application created with AWS RoboMaker. We offer 6 different sample applications. The Hello World sample application is bare bones robot running in an empty world. It's a great place to get started if you want to explore maybe plugging in your own robot or seeing exactly how the project structure is set up. Our other sample applications highlight our different cloud service integrations. So the robot monitoring has CloudWatch integration built in. Navigation and person recognition is using Kinesis video streams and recognition video. The voice command sample has a Lexbot integrated for both voice and text-based control of the robot. And then we have 2 reinforcement learning sample applications, which show how to train or how you can train models in simulation. So I'm going to kick off the Hello World sample application. Once we've started the creation process, what we're doing behind the scenes is running a CloudFormation stack, which is provisioning all of the AWS RoboMaker resources you need and starting the simulation. If there's any additional resources that are needed, they're started up as well. So if you need a KVS stream or a Lexbot or a Lambda function, all of that will be provisioned behind the scenes and will drop you into a running simulation job. So I'm going to skip forward to a simulation that I already have running. So once those resources are provisioned, you'll end up on the simulation detail view, which looks like this. Each simulation has an ID and an R if you want to reference the simulation from outside the service. You can see the status of your simulation. It can be preparing, running, canceled, or failed. The date that the simulation was started. When the simulation is running, each of the GUI tools is available to be opened directly from the simulation. I'm going to skip over those for now and come back to them in a bit. And then we've got some configuration information on the simulation itself. We can see the duration that was requested for the simulation. You can run a simulation for up to 14 days. The failure behavior can be either continue or fail. If you're using the simulation in a development loop, continue is probably a failure behavior you'd prefer. If there is an error, the simulation host will continue to run so that you can restart quickly, perhaps after you've shipped a code change. And the terminate failure behavior is useful if you're running regression tests. You want to go ahead and stop so you can inspect the error. In theory, you have many, many simulations running in parallel, and so you don't want to continue to have that host run. The IAM role. So this is a role that we're going to be using while the code is executing in simulation. So if your robot code is reaching out to AWS resources, calling a Lambda function or logging metrics, this role needs to have the appropriate permissions to make those calls. I mentioned earlier that we'll write logs back to your S3 bucket for things like ROS bags or the simulation log. You can link directly to that content from the simulation job output destination. And then we've got metrics and logs on the simulation itself. So we send standard out and standard error from the robot and simulation application to CloudWatch logs, and then metrics on the actual simulation itself, things like real-time factor, we write to CloudWatch metrics directly. So if we take a quick look at the networking tab, if you did configure external networking, you can see your subnet security groups and whether or not you have a public IP. And then we've got the robot application and the simulation application. So this is the code that's actually running under simulation. You can link directly to the resources. Both robot application and simulation application are versioned. You can see the package name as well as the launch command that we're going to run in simulation, and then any environment variables that you set up. Both the simulation application and robot application are very similar. All right, so that's a bit of the metadata that's exposed for running simulation. One last thing I'll mention is that simulation jobs can be restarted if they're running, canceled, or cloned. Clone is super useful if you have either a running or a terminated simulation job. It's a quick way to restart it. All right, so we've seen some of the metadata that's exposed for a running simulation job. Let's talk about the simulation tools themselves. We offer 4 different GUI tools. These are all running on the server. They're rendered on the simulation host, and we stream the content to a viewer in the browser. So Gazebo is the Gazebo thick client, which we can use to interact with the physical world in simulation. RQT and RViz are utilities that come from the ROS ecosystem, which we can use to visualize information about the robot, what it's seen, and how it views the world. And then we have a basic terminal that you can use to interact with ROS commands from the command line. So I'll pop each one of these open and we'll take a look. Now we're running our CloudWatch sample application here, and we can see the simulated world that the robot is moving around in. In this case, this is our bookstore simulated world. We offer 3 different simulation assets that you can use to build your own simulations quickly. There's the bookstore, which you can see here, a home, as well as a racetrack. So we can see that we can fly around in the simulated world, and we can see our robot is moving through the world here. So with the Gazebo client, you can play around with all sorts of stuff in the physical world. You can adjust the lighting, the physics, or just take a look and find out, if your robot's stuck, where is it stuck? If we pop open RQT, one of the nice things you can do with RQT is take a look at different sensors that are on the robot. So we can use it to take a look at the camera. On this robot, we've got a front-mounted camera, so we can see the view of the simulation rendered from the point of view of the robot sensor. If we pop open RViz, there's a bunch of different things we can do with RViz, but one of the neat ones is to actually see the SLAM map that the robot has generated. So with our sample applications, we've got some pre-installed maps. Let's go to the Turtlebot. So what we see here is the view of the world that the robot has generated from its onboard sensors. Just expand this a bit. So the robot has mapped out its environment, and we're visualizing it as the robot visualizes it while it's navigating through the world. So in this particular sample application, we give the robot random points to navigate through, which you can see at the end of the line here. And then the line itself is the path that the robot has planned to take to get to the route. All right, so that's Gazebo, RQT, and RViz. And then lastly, we've got a terminal application, which you can use to run the basic ROS commands that you're used to running on the simulation running in the cloud. So we can take a look at the different ROS topics and interact with them. So this is great if you want to debug something or maybe interject some information directly into a ROS topic while the simulation is executing. All right. So we've talked about some of the metadata around a running simulation, and we've explored the different tools that are offered with AWS RoboMaker. Let's jump into development. I mentioned earlier that we've got integration directly to Cloud9, so you can create a AWS RoboMaker Cloud9 development environment pretty quickly from the RoboMaker console. You just have to give it a name and choose an instance type, and then pick a VPC, which is necessary for Cloud9 to reach out to the EC2 instance the IDE will be running on. So we've created a development environment. You know, what's happening behind the scenes right now is Cloud9 is reaching out and using one of the AWS RoboMaker custom-built AMIs to create a development environment on an EC2 instance in your account. And that EC2 instance will have all of the ROS tooling and dependencies in order for you to build, bundle, and deploy robots in the simulation. So let me open up a IDE that I created before. So this looks very similar to the vanilla Cloud9 IDE, with the exception that we've got some additional utilities up here at the top. The run menu allows you to build, bundle, and launch simulations, same software development lifecycle we talked about before. And you can combine those into workflows. So if you want to have a one-click, which will build, bundle, upload to S3, and restart a simulation, you can set that up. We've got the simulation tab, which you can use to connect to running simulations. So I'll go ahead and connect here. Once I'm connected, you can see the standard out from the simulation and robot applications is being streamed down from CloudWatch logs directly to the IDE. And now that we're connected, we can stop, start, or restart our running simulation, as well as connect directly to the GUI tools that we just talked about from the IDE. So this is super useful if you're making code changes and maybe you want to see that the pose of the robot is correct or the robot's behaving in the proper manner. You can connect directly to the GUI tools from the IDE. And then lastly, we've got RoboMaker resources. So you can jump directly to any of our cloud service extensions from the IDE, or you can download the sample application code. So the samples that we talked about before are all available here from source. So if you wanted to dive in and understand exactly how they work or use them as a starting point for your own code, they're available. And you can download them directly into the IDE. All right, so we've talked about some of the AWS RoboMaker architecture that supports simulation in the cloud, which components live in the service and which components live in your account. Covered some of the RoboMaker nomenclature and the resource types, started the simulation, explored the simulation and the GUI tools that are available to interact with it, and gone over some of the IDE features we offer with AWS RoboMaker. All right, and that concludes the demonstration and overview of simulation in AWS RoboMaker. Thank you all for joining.